So standard 11, we are in Math 2 sequences and series. This is lecture number 1. We are dealing with exercise 2.1. Question number 1. Check whether the following are the GP or not. If so, means if they are the GPs, then find Tn. So two questions I have selected from this. The first one is 1 minus 5, 25 minus 125 and so on. Solutions I will write here. Second one 1 minus 5, 25 minus 125 and so on. Here T1 is equal to 1, T2 equal to minus 5, T3 equal to 25 and T4 equal to minus 125. If they are the GPs, then the ratio should be constant. For the EP, the difference should be constant, and for the GP, the ratio should be constant. So the next term upon the earlier term. So T2 upon T1 is equal to, T2 is minus 5 upon 1 is equal to minus 5. Then T3 upon T2, next term upon the earlier term, T3 upon T2 is equal to, T3 is 25 upon minus 5, that is equal to minus 5. Now the T4 upon T3, T4 upon T3 is equal to, T4 is minus 125 upon 25 is equal to minus 5. Therefore, T2 upon T1 is equal to T3. T2 upon T3 I will take. T2 upon T3 is equal to, not T2, T3 upon T2. Then T4 upon T3, and that is all minus 5. Therefore, the ratio R is equal to minus 5, which is constant. Now Tn is equal to A into R raised to n minus 1. Therefore, Tn equal to A is what? The ratio R is equal to minus 5 and A equal to the first term, A equal to how much? 1. Therefore, Tn is equal to 1 into R raised to, R is what? Minus 5 raised to n minus 1. So that is equal to minus 5 raised to n minus 1. This is the nth term. Let me see whether you can have the view of that screen. Yes. So this is the answer for one number. Now this second number. Now the third one I will take. Third one is root 5, comma 1 upon root 5, comma 1 upon 5 root 5, comma 1 upon 25 root 5 and so on. Here T1 equal to root 5, T2 equal to 1 upon root 5, T3 equal to 1 upon 5 root 5 and T4 equal to 1 upon 25 root 5. Now I have to take the ratio T2 upon T1, T3 upon T2 and T3 upon T3. So T2 upon T1 is equal to, T2 is how much? 1 upon root 5 upon root 5. Some of the students may struggle to solve this. Actually this is root 5 upon 1, this T1. So divided by means what? 1 upon root 5 this into this will become 1 upon root 5, the inverted of this 1 upon root 5, and that is equal to 1 upon root 5 to root 5 is 5. T3 upon T2. What is T3? 1 upon 5 root 5 divided by T2. T2 is 1 upon root 5. 1 upon root 5. That is equal to, this will be inverted now. 1 upon 5 root 5. This will become root 5 upon 1. This root 5 cancel, and that is equal to 1 upon 5. Now T4 upon T3 is equal to, T4 is 1 upon 25 root 5 divided by T3 is 1 upon 5 root 5. So this is equal to, this will be 1 upon 25 root 5. This will become 5 root 5 upon 1. This will get cancelled, this will get cancelled, and 5 1s are 5 5s are, that is equal to 1 upon 5. Therefore, T2 upon T1 is equal to T3 upon T2 is equal to T4 upon T3 is equal to 1 upon 5, which is constant. Here we will write which is constant. Which is constant. Constant. Here also you should write which is constant. Therefore, R is equal to 1 upon 5 and N is the first term, A equal to root 5. So now Tn is equal to A into R raised to N minus 1. That is equal to A is what? Root 5 into R is how much? 1 upon 5 raised to N minus 1. If you want to simplify this you can simplify like this. Tn is equal to root 5 into 1 upon 5 raised to N minus 1. Because for 1, whatever the power, it will remain this much only. So, this is the completion of question number 1. The remaining sums you can solve. Now I will go for the second question. There also I will describe in a brief. The second question is for the GP, question 2. For the GP, if R equal to this number 1, R is equal to 1 upon 3, A equal to 9, find T7. Seventh term is equal to question mark. This is the first question. Answer for this is, answer or solution, Tn is equal to A into R raised to N minus 1. This is the formula. Now I have to find T7. T7 is equal to A is how much? 9 into R is how much? 1 upon 3 raised to 7 minus 1. This is N minus 1. So here it is 7. So 7 minus 1. That is equal to 9 into 1 upon 3 raised to 6. So that is equal to 9 into 1 upon 3 raised to 6. 1's power is 6. That is 1 only. So if you want to solve this, then it will be 9 into 1 upon 3 into 3 into 3 into 3 into 3 into 3, 2, 4, 6. These 3 will get cancelled, and that is equal to 1 upon 3 3 is 9, 9 3 is 27, and that is 1 upon 81. So this way you have to solve it. So now the question which I will take is third question. I will take that is a slight difference. The third one is R is equal to minus 3, T6 equal to 1701, and A equal to question mark. So Tn is equal to A into R raised to n minus 1. This T6 is given, therefore T6 equal to A is how much? That we don't know. A I have to find. Into R raised to R is minus 3, raised to n is 6, 6 minus 1. Therefore, but T6 is given to be 1701. That is equal to A into minus 3 raised to 5. So now I have to find the value of A. Therefore, 1701, this is into, it will become upon here. So this will be minus 3 raised to 5. That is equal to A. Now I have to solve this. So I will go on simply dividing. Therefore, A is equal to 1701 divided by minus 3 into minus 3 into minus 3 into minus 3 into minus 3. 3 raised to minus 3 raised to 5 means this minus 3 will be for 5 times. 1, 2, 3, 4 and 5. So anyhow, this division, this minus into minus will become plus. This will become minus, then will become plus, and then it will become minus. So that is nothing but 1701 upon this minus into minus will be plus. This minus into minus will become plus, and this is minus, so minus. 3 into 3 into 3 into 3 into 3. 3 into 5. Now I can divide this by 3. Why? Because 7 plus 1 8, 8 plus 1 9. It is in the table of 3 and 9 also. By 9 also I can divide, and by 3 also I can divide. I will divide 1 by 1. 3 ones are 3. 3 5s are 15. Remains 2. 3 6s are 18. Remains 2. This take 1. And 3 7s are 21. Once again I can divide by 3. Why? 6 plus 5, 11, and this 18. So by this 3 I will. 3 1s are 3, remains 2, take this 6. 3 8s are 24, means 8s are 24, remains 2, they take 7, 3 9s are 27. Then again by this 3, 3 1s are, 3 6s are 18, 3 3s are 9. Then 3 1s are, 3 2s are 6, 3 1s are, and 3 1s are 7. So this answer, therefore A equal to, I will write minus 7. This minus this 7. So this way this question is over. Hope that you have understood this. The fourth question I will solve That is also of the same type. But there is some adjustment that you should understand. Some of the students may not have the confidence of taking this. So fourth one is A is equal to 2 upon 3. T6 is equal to 162. Find R. Just the formula Tn is equal to A into R raised to n minus 1. Therefore, T6 is given, so I will write T6 equal to A into A is how much? 2 upon 3 into R is how much? That I don't know. R raised to n minus 1. What is the value of T6? 162. Therefore, 162 is equal to R this 2 upon 3 into R raised to n minus 1. This dot means into. Now bring this 2 upon 3 here. It will become therefore 162 into 3 upon 2. This divided by become into. This into will become upon. Is equal to R raised to n minus 1. 2 ones are 2 8 are 16 and 2 ones are. Therefore, this is 81 into 3 is equal to R raised to n minus 1. Now, this is 3 raised to 4. So, 3 raised to 4 into 3, this 3 is equal to R raised to n minus 1. Therefore, 3 raised to it will be 5. 3 raised to 5. Oh, here I have done a mistake. I would have put here 6 at the last step instead of taking. So here I will write 5, 5, 5 and this 5. I will go on in the initial step only. So 3 raised to 5 is equal to R raised to 5. Now see that the indices are same. Therefore, taking the fifth root, R is equal to 3. This. And what is the reason if you want to give taking the fifth root? Taking fifth root. The answer also, what the reason, that also you should understand. So this is all with this question number 2. Now question number 3. Here onward the difficulty level will go on increasing. But anyhow, you have dealt with such questions in standard 10 in AP. Question 3. Which term of the GP five, 25, 125, 5, 25, 125, 625 and so on is 5 raised to 10. So Tn is equal to how much? The last time is given solution. It is a GP solution. R is equal to 25 upon 5. Here we need not to go on dividing all the terms. Only one, because it is a GP. That is equal to 5. A is also 5. A is also 5. This is the last term. So Tn is equal to 5 raised to 10. Now what is the formula? Tn is equal to A into R raised to n minus 1. But Tn is 5 raised to 10. 5 raised to 10 is equal to A is how much? 5 into R is how much? R is also 5. 5 raised to n minus 1. Therefore, I will divide by this 5 here. or I can add them here also. So 5 raised to 10 is equal to 5 raised to this 5 raised to n minus 1, and this is raised to 1, it will become plus. Multiplication means addition of the indices. Therefore 5 raised to 10 is equal to 5 raised to n. So what is the value of n? N is, this is the 10th term. So hope that you have understood. Only you have to write. Therefore n is equal to 10. Therefore the 10th term, n is 10 means T10, 10th term is 5 raised to 10. Question number 4. Question 4. For what value of x, for what value of x, the terms 4/3, comma x, comma 4/27 are in GP. These are the four terms, they are in GP. Solution. Here T1 is equal to 4/3, T2 is equal to x, T3 equal to 4/27. If these numbers are in GP, they are given. These numbers are in GP. Therefore, T2/T1 is equal to T3/T2. Therefore, T2 is what? T2 is x upon T1 is what? 4/3 is equal to. T3 is what? 4/27 upon T2 is what? X. So do the cross multiplication now. Therefore, x into x is x square is equal to this into this. So 4/27 into 4/3. Cross multiplication. Or if suppose you have the problem, you can solve this 3x/4 and then take it there. Therefore, x square is equal to, this is 16 upon, how much it is? 81. So now what is that? Then take the square root of it and then you will get it. Okay. Have you understood this? So therefore x is equal to, the square root can be plus or minus 4/9. So for the value x equal to plus or minus 4/9, the given is the GP. So now question number 4. For 4 marks, this question number 4 will be, fifth will be asked. This question number 4 we have done, it is for 2 marks. And for now 4 mark question. Pay attention to this. If for a sequence Tn equal to 5 raised to n minus 3 upon 2 raised to n minus 3. Show that the given sequence is a GP. It is a GP. Find first term A and the common ratio R. So these are the two questions. This means two various things needed over here. So solution. See this. Suppose it is a GP and the 3, 6 and so on. What is the next term? This is T1. This is T2. And here what is the term? T3. How you got? T2 plus 1 will give you this term. Or the next term. And if I have to find the ratio, I will find T3 upon T2. This way. Next term upon the earlier term. Now here in this case only one term is given. I should get the next term. So next term how I will get? If suppose this is T7, next term will be T8. So solution Tn is equal to 5 raised to n minus 3 upon 2 raised to n minus 3. This is the Tn. If I want to find the ratio, means if I want to show that it is a GP. So what I have to do? I have to divide the two numbers. Which two numbers? The next term and the earlier term. I have to divide it. I don't know the next term. Next term will be Tn plus 1. This will be the next term. That is equal to mean at the place of n, I am writing n plus 1. So 5 raised to, at the place of n, what I have written? N plus 1. This minus 3 upon 2 raised to, at the place of n, n plus 1 minus 3. So therefore Tn plus 1 means the next term to this is equal to 5 raised to n minus 2 upon 2 raised to n minus 2. See this. Now I will take the ratio. How I will take the ratio? Tn plus 1 upon Tn. Because the next term upon the earlier term. This is the next term. Upon the earlier term is Tn is equal to. Tn plus 1 is this. So 5 raised to n minus 2 upon 2 raised to n minus 2 upon. Now Tn is what? 5 raised to n minus 3 upon 2 raised to n minus 3. Now how I divide this? I will multiply it by taking the inverted of this. That is equal to 5 raised to n minus 2 upon 2 raised to n minus 2, and this I will flip it. 2 raised to n minus 3 upon 5 raised to n minus 3. Now, see this is the division. Division means subtraction of the indices. What I will do is, I will take this up, means n minus 3 will become minus. This I will take up, this will become minus. So, that is equal to, this division I have to do. This is Tn plus 1, this much. This is a Tn. Divide this. Division I will do by multiplying it. So, now the base for this is same. Division it is, means subtraction of the indices. If I take this index up, it will become minus. So that is equal to n minus 2. Sorry, n minus 2 minus this, because I am shifting this up, minus n minus 3. This part is over. Now this I will bring down upon. Why taking this down? Because it will become positive. So 2 raised to n minus 2. This I will take down. and minus n minus 3. So that is equal to 5 raised to n minus 2 minus n plus 3 upon 2 raised to n minus 2 minus n plus 3. So that is equal to, this will get cancelled and this will be 5 raised to 1 upon 2 raised to 1. This will get cancelled. So that is equal to 5 upon 2, which is constant. Which is constant. Therefore, this is R is equal to 5 upon 2. In the textbook, it is written for all n. This way. For all n. If you want to write, you can write. Okay. The first term I want to find. Therefore, Tn equal to 5 raised to n minus 3 upon 2 raised to n minus 3 is a GP. It is a geometric progression. Why? R is constant. That's why it is a GP. Therefore, T1 I want to find because I want to find the first term. T1 is equal to 5 raised to, at the place of n I will write 1 minus 3 upon 2 raised to 1 minus 3. That is equal to 5 raised to minus 2 upon 2 raised to minus 2. Now both the indices are negative. To make them positive, I will write like this. Here I will write, that is equal to this 2 raised to 2 up, it will become positive. This I will take down, 5 raised to 2 and 2 raised to 2 is 4, 5 raised to 2 is 25. Therefore, A equal to, the first term equal to 4 upon 25. Hope that you have understood, because this was a very, very important question. So the question number 6 is also there. There are many questions in this. I will select the question. Question 6. Find 3 numbers in the GP. Find 3 numbers in a GP such that their sum is 21, sum equal to 21, and sum of their squares and sum of their squares. Sum of squares, in short I will write squares, is equal to 189. So while in the standard this 10, while assuming in the AP, we were assuming like this 3, A minus D and A plus D. This way we were assuming for the AP. Now it is a GP, so how to arrange that? Assume that solution is, let the 3 terms be A upon R, A and AR. See, the ratio is constant. Once again I will tell, this is T1, this is T2 and this is T3. Ratio should be constant. I will check. This upon this, A upon R is equal to A into R upon A, cut, ratio is R. If I take this A cut, ratio will be R. Okay. Such that their sum is 21. Their sum is which sum? all these terms sum we will take. Okay. From first from first condition, A upon R plus A plus AR is equal to 21. What is common? A is common. Therefore, A into 1 upon R plus 1 plus R is equal to 21. So, this was the first condition. Hope that you have understood this. Now, if you want to simplify this, you can simplify this. So, this I will give number 1. From second condition, what is the second condition? Sum of the squares. Sum of the squares means square of this plus square of this plus square of this will be 189. From second condition, A upon R square plus A square plus AR square is equal to 189. Therefore, this will be A square upon R square plus A square plus A square R square is equal to 189. Therefore, what is common? A square is common. I will take A square as common. What is remaining here? 1 upon R square plus 1 plus R square is equal to 189. This is number 2. Hope that you have understood. Means this much part you should understand it. So now, if I square the first number is this. If I square this, I will get A square, and I will get this also something. What is that thing you will get? So, how to square this? That is important. In standard 8, you have the formula. This I can square, but this how? A plus B plus C bracket square is equal to A square plus B square plus C square plus 2AB plus 2BC plus 2CA. This was the formula. Same formula I will use for this. Okay. On squaring, equation 1. Note down that formula because I am going to rub it. A square into 1 upon R plus 1 plus R bracket square is equal to 21 square. Squaring both the sides. Okay. Therefore, now I have to expand this. Therefore, A square into bracket. I am going to rub that formula now. One upon R square plus 1 square is 1 plus R square plus. See this, for you I am just once again writing A plus B plus C bracket square is equal to A square plus B square plus C square plus 2AB plus 2BC plus 2CA. This was the formula. So, the multiplication and twice of this. So, 2 upon R. Multiplication and it twice. Plus, this is over. Now, 2R. this plus this into this and it's twice. 1 upon r into r is 1. So this will be 2. Check this along with this. A square plus b square plus c square plus 2ab. 2 times of this and this. 2 times of this and this will be 2 upon r plus 2 times of this and this. 1 into r is r. Is twice is 2r plus now 2ca. 1 upon r into r cut and it 2 plus 2. That is equal to, so 21 square is 441. This one. Therefore, a square into this much part 1 upon r square plus 1 plus r square. This much part. See this. Plus 2 is common over here. 2 into bracket. Here it will be 1 upon r plus r and plus 1 is equal to 441. Hope that you have understood this. Now check all your equations. So this 1 upon r plus 1 plus r, we have something for this. This is only a square, that's it. So out of this a square and this I will write here. Therefore, a square into 1 upon r square plus 1 plus r square. This much part value I have. Where it is at? Here. Plus. Now this a square is multiplied here also. 2a square into 1 upon r plus 1 is equal to 441. This is just the adjustment part. This is a square is for this also. This a square is for this also. Therefore, what is the value of this? Check it. This is 189. So 189 plus this is 2a into 1 upon r plus 1 is equal to 441. Check it. Why I am doing this? Because I know this. So this much part I know. This much part is 21. So this 189 I will take there. Therefore 2a into this much part is 21. Here I will write for this from 2. This from 2. 2a into this is 21 is equal to 441 minus 189. Here I will write from 1. That is equal to 2a into 21 is equal to 441 minus 189. 9 plus 2, 11. 9, 5, 1, 252. Therefore, a equal to 252 divided by 2 into 21. So 2 1s are 2 1s are 2 2s are 2 6s are and 21 6s are 126 and therefore a equal to 6. So a I got. So I am rubbing the formula. A is equal to 6 I got. Now what I want? I want R. In this equation, you put the value. So now I am rubbing this. Here I am considering this equation. Once again I will take the equation number 1. Therefore, A is how much? 6. 6 into 1 upon R plus 1 plus R is equal to 21. Therefore, this 6 will become divided over that. Okay. And then I will go on. Or 3 to the 6, 3 7 the 21. That way I will take. So 2 into this I will solve now. This is r in the denominator. So multiply each term by r. If I multiply this by r, it will be 1. Plus, if I multiply this by r, it will be r. If I multiply this by r, it will be r square. And I am multiplying for this also. This is equal to 7r. Therefore, this equation is 2r square plus 2r plus 2 and this minus 7r is equal to 0. Hope that you have understood. I am changing the pen now. So, what you want? You want to do something for this, factorize this. Therefore, first of all, I will write 2r square. For this and this, it will become minus 5r. And this is plus 2 is equal to 0. Hope that you have understood this well. So now, I am rubbing this part also now. I have to factorize this. This 2 to the 4. Find the factors of 4 such that their addition is minus 5. Therefore, 2r square minus c is 2 to the 4. 4. I want to find the factor. Their addition should be minus 5. So that is equal to 4 1. Addition means I will have to give the same signs. So minus 4r minus 1r plus 2 is equal to 0. Make the two groups. Therefore, 2r is common. Here remains r minus here remains 2 minus 1 r minus 2. Therefore, r minus 2 into another bracket 2r minus 1 is equal to 0. Therefore, r minus 2 is equal to 0 or 2r minus 1 is equal to 0. Therefore, r is equal to 2 or 2 means r is equal to this minus 1 will become plus and this is into will become upon. So these are the two values. So I got two values of r. R values are 2, 1 upon 2. Now I will come to the main question. Find the terms. So the terms are, the numbers are, what is a upon r, comma a, comma a r. Therefore, a is what? 6 upon r 2, comma a 6, a 6, r 2, 6 into 2. When r is equal to 2. Then this will be 2 3s are 6 and 12. These are the numbers. This is one answer. But r has two values. Or when r is equal to 1 upon 2, that time what are the numbers? A upon r. A means 6 upon r is how much? 1 upon 2, comma a is 6, comma a 6 into r. R is how much? 1 upon 2. That is, this will become, into will become 12. 6, 2 1 are 3. Answer. The numbers are 3 6 12, 3 6 12 or 12, 6, 3. 12, 6, 3. This is your final answer. And here we will stop this video because the video has become very lengthy. And then afterwards we will select the next questions. From 7th onwards we will see afterwards. Here I stop the video.